Hi, I'm Paul Mason, and this is Callisto in a nutshell. And we can begin by comparing Callisto, which is one of the moons of Jupiter, with the Earth and our moon. And the moon is, we can see Callisto is substantially larger than our moon and substantially smaller than the Earth. And one of the things we can think about is that Callisto is only just a little bit smaller than the smallest planet, Mercury. And Callisto is the third largest moon in the solar system after Ganymede, Titan, and then there's Callisto. And but the difference here between Callisto and the moon and the Earth, the big difference is that Callisto is about half ice, water ice that is mixed throughout Callisto, but mainly in the surface and below that. And there may be a liquid water ocean beneath the surface, probably is a liquid water ocean, and a lot of soil, which silicate material, rock, mixed with ice in a crust, and probably a liquid, muddy kind of ocean below that. Substantially different than the moon, which is a pure rock kind of object. So, and the Earth, which only has ice at the polar caps for the most part. So, well, it's not surprising. We see that when we look at these moons here orbiting Jupiter, we have Io, Europa, Ganymede, and then here is Callisto orbiting around the slowest, because it's the furthest out of these, the four Galilean moons, the four moons discovered by Galileo in about 1610. And so Callisto, which we can't see in detail here, but always shows the same face towards Jupiter. The other three moons also always show the same face towards Jupiter. This is like what we have with the moon and the Earth. The moon always shows the same face to the Earth. The tides, this is caused by the tidal effects of Jupiter on these moons. Now the tidal effects are strong enough that a Europa and Io, Ganymede, and Europa all are in resonant orbits, whereas Callisto is not. So Callisto is the least affected by the tides of Jupiter, but it is affected by the tides. It is in synchronous rotation with its orbit. So that means it spins one time for every one orbit around Jupiter. And so that takes a little over a couple of weeks. If we compare these different moons, we can see here from closest to Jupiter, Io, Europa, Ganymede. Callisto is the furthest out. Callisto is the second largest moon. Ganymede is the largest moon in the Jupiter system and the largest moon in the solar system. And Callisto is the third largest moon in the solar system, second in Jupiter's system. But it's very different. It's more like Ganymede than Europa and Io because of the tidal effects. The ice has been removed from Io, and the Europa is very smooth. Callisto has many craters, and it has lots of impacts shown by the very white features that show ice, impacts of comets and such, more recent than the darker regions. And so Callisto is, like Ganymede, made a lot of ice, so its density is lower. In fact, as I mentioned Mercury is just very slightly larger than Callisto and smaller than Ganymede, but Mercury is an iron, has a huge iron core and rock crust. The density of Mercury is about 3 times the density of Callisto, and Callisto is the least dense of all of the moons and in these large moons of Jupiter. And so from its density we can tell that it's made probably about half ice and half rock, with maybe some iron maybe in the core, and not as much iron though as other objects, but about half ice. So we can think about the 7 large moons of the solar system and see where we fit here. The Ganymede, moon of Jupiter; Titan with a thick atmosphere, moon of Saturn; and then the 3rd largest is Callisto. So still smaller is Io and our own moon, and Europa, another moon of Jupiter; and Triton, moon of Neptune. So these all are interesting to compare the differences and similarities between them, because they can tell us a lot about what the solar system has been like for a long time and how these got to be the way they are. And so Callisto is covered by many, many craters. It has the oldest surface of any of the large moons. What we mean by that is that the surface has not changed over a very long period of time, and really unchanged since not long after it was formed. The only geological effects are a very weak tidal force from Jupiter, and maybe some very small effects from that. Most of the effects of the changing surface are due to impacts of objects, and the number of impacts was very high in the early solar system and has decreased, but it still continues today. But that's where we see most of the change has happened on Callisto. And we can see the famous Valhalla crater, which is a huge multi-ring impact feature. So we can see the feature here. We can tell that this is the limb of the moon, so it's this very large feature, and there are rings that go out here very, very far away. And so we got to remember this is all ice, and an impact here